this thing. Okay. So we want to do this. Okay. So that's adding two fractions basically. So let's think back to what we do when we add two fractions. If we would do 3/5 plus 4/7, the common denominator is going to be 5 times 7, right? How do we get a common denominator of 5 times 7? Well, 3/5 has a denominator of 5. We're going to have to multiply 5 by 7, right? But that changes the value of the fraction unless we also multiply by 7 in the numerator. So what we do is we multiply 3/5 by 7 over 7. 7 over 7 is just 1, so that doesn't change the value. That gives us 21 over 5 times 7. Now, I keep this one factor, 5 times 7, for reasons that we'll see in a minute. Okay? So that's 21 over 35, and you know that that reduces, if you think about it, that does reduce to 3 over 5. So when we multiply by 7 over 7, we didn't change the value of the fraction. The decimal equivalent of this fraction would still be 0.6. Okay? But we don't have to worry about that. We just know if we multiply by 1, it isn't going to change the value. That's the first principle we got to understand. So if we multiply this by 1 in the form of 7 over 7, we get a denominator that's going to be 5 times 7. Over here, our denominator is 7. Well, to get the same denominator, we have to multiply 7 by 5. So we got to multiply 7 by 5. We can't just multiply 7 by 5. We got to multiply the whole fraction by 5 over 5. For the same reason, that doesn't change the value of the fraction. Okay, that's the first step. Now, how does that play out up here? Okay, we're not going to worry about the rest of it for a minute. Let's see what we do there. So just as guidance. Now, again, you really have to understand this process for numbers. And people did pretty well with fractions early in the course, but you might want to review it. Okay, you might want to make sure you know how to add two fractions. Because if you don't, you're going to get confused in what you do here. Okay, so let's just say this is x minus 5 over x plus 7 plus x plus 9 over x minus 12. Okay. So that's analogous to what we have here. What's that equal? Well, our common denominator is going to be x plus 7 times x minus 12, right? So we want to write that out. And if you're not writing it out, well, start writing it out. Okay. You want to write out every step until they start making sense to you and you understand why you're doing it. So common denominator is x plus 7 times x minus 12. And that should be obvious. Okay. Just as it's obvious that up here, your common denominator has got to contain a 5, it's got to contain a 7. Okay. This one's got to contain this, contain this. This is how you do it. Okay, so we want the denominator to come out this way, meaning that we have to multiply the denominator by x minus 12. So we can't just multiply the denominator by x minus 12. We have to also multiply the numerator by x minus 12 to keep things balanced, to keep the fraction the same. In other words, we multiply this fraction by 1, because this is 1. Okay? And then it's plus x plus 9 over x minus 12 times what? Well, you have to get a denominator of x plus 7 times x minus 12. To do that, you multiply the denominator by x plus 7. Meaning you also have to multiply the numerator by x plus 7. So you multiply by 1. Okay? Now, that then equals x minus 5 times x minus 12 over x plus 7 times x minus 12. 9 times x plus 7 over x minus 12 times x minus 12. Now, this is completely analogous to the step that I didn't write, okay? That I probably should have. I was trying to conserve board space. But that's like saying, okay, this is 3 times 7, and this is 4 times 5, right? And of course, that equals 21, and this equals 20. Okay, now that's easy with numbers. Here, you probably want to write out this intermediate step here to make sure you see it. Another thing you can see when you look at this is, well, x minus 12 over x minus 12 divides out, and it leaves you with x minus 5 times x plus 7, which is what you had to start with. Over here, uh-oh. That what you're going to say? Okay, just a minute. Over here, and I'm glad I did that because I wrote that down carelessly, did too much of that. I have x plus 7 over x plus 7. Well, that divides out, leaves me x plus 9 over x minus 12, which is what we have here. So we can see at this point very easily that what we have here is the same as what we have here. It just looks different. Now, we have a question, so I'm going to stop and take a question. Okay, we had a good question, but it comes a little bit later, so I'll address it when we get there. Okay, now what we do is we multiply the numerators. Okay, and we use the distributive law. You can't multiply these without using the distributive law, and I don't recommend you go to a bunch of tricks. I mean, if you draw your arcs here and here and here and here, that gets it done. But I really prefer that you write it out completely until you're totally comfortable with the distributive law. It reinforces the distributive law, and if you don't keep reinforcing it, you're not going to understand it as well when you really need it in your pre-calculus course, okay? Okay, so anyhow, we multiply this out. Now, I'm not going to write out the details of the distributive law, but here, x times x minus 12 minus 5 times x minus 12, okay? And then that's going to give you x times x minus x times 12 and negative 5 times x, negative 5 times negative 12. You write that out in 2 steps. Keep reinforcing the distributive law because it's really easy to write things down wrong because it looks like what they ought to be. Okay? Okay, so we have x minus 5 times x minus 12. That's going to give us x squared at 17x plus 6. That's over x plus 7. X minus 12. Now that's just like what we got here, where we multiplied the numerators. Now 3 times 7 is a lot easier than x minus 5 times x minus 12. But x minus 5 times x minus 12 is not hard if you use the distributive law and be careful about it. Okay, there's nothing really terribly difficult about it. Okay, well, anyhow, x plus 9 times x plus 7 is going to give us x squared plus 16x, 53. Okay. So now we've completed a step that's analogous to what we did here, multiplied out our numerators. What did we do next? We wrote it out. And write out the steps like I'm doing it because, again, you don't want to lose track of why you're doing what you're doing. You don't want to do it just out of habit because you're going to lose the habit. Okay. As an example, on the midterm test, okay, nobody did very well, I don't think. Maybe one person, I don't remember who, with solving a pair of simultaneous linear equations or graphing a linear equation. Okay. Now that's because you didn't totally understand the principle, okay? And you didn't remember what to do. Now, not being critical, I'm just pointing out that that's the reason you try to understand it as deeply as you can when you do it the first time. Okay, we're going to review that a little bit. But end of digression. Let's move on here. Okay, what's the next thing we do? Well, we have this. Well, we know we can add the numerators because of the distributive law. Distributive law tells us that this plus this over this is this over this, which is here, plus this over this, which is here. And it's the distributive law. This is really multiplication by the reciprocal of 5 times 7, right? Like we multiplied 21 plus 20 times 1 over 5 times 7. Multiply the numerators, multiply the denominators, this is what we get. Anyhow, that's a distributive law. The distributive law applies to division because division is just another form of multiplication by the reciprocal. Okay. It's another form of multiplication, which is multiplication by the reciprocal. Okay, anyhow, here now we can say that this is x squared minus 17x plus 60. I'll put parentheses around that. Not really necessary, but this is good. Okay, this is the same as this, because of the distributive law. Now we can add these, and everybody I think knows how to do that. X squared plus x squared is 2x squared. Negative 17x and 16x is minus x. And 1663 is 123. And we divide that by x plus 7 times x minus 12. Now the question I had is why don't we multiply out the denominator? It's because the next thing we do, the way we finish this off, is we factor the numerator, if possible. It's not possible in this case, but we often will see problems that are kind of contrived so that when you factor the numerator, one of the factors or more passes a factor in the denominator. Okay? That usually doesn't happen in the wild. Okay? If you get a real life problem, it's unlikely that the numerator is going to factor, but it could. So you check it out because that would simplify things. Now, I can tell right away the numerator won't factor. I just check it with the discriminant using the quadratic formula and I get a negative under the radical. If it was going to factor, it would have zeros. As a factored polynomial, a fat polynomial that factors into linear binomials, okay? Linear factors will have zeros. And since you have a negative under the discriminant, or since the discriminant is negative, meaning you have a negative under the square root, this can't equal 0, so it won't factor. Okay? That's kind of a shortcut to being able to test whether some of the factors or not. It can also tell you what the factors are, but not going to worry too much about that. Okay, so this doesn't factor. So let's just kind of this last little step. A little hard to read that word. This doesn't factor, so we can expand the denominator. Not that we couldn't have expanded it before. Okay. But if we did, and then found that the numerator factor, we'd have to refactor the thing. Of course, we already know what the factors are, so that won't be a big deal. So it's kind of optional. If I multiply this right, that's x squared minus 5x minus 84. I'll just make a note that it's optional to do that. That's the process. Now, this is only with linear factors, okay? And it's about the simplest example you can do with rational expressions. There are shortcuts for this that don't apply in all cases. I don't recommend you use shortcuts. I recommend you do all the details here, which summarizes a whole lot of the algebra that we've learned. Okay? It'll make you stronger across the board. And it'll force you to think about why this works and how it works. Again, you want to start by being sure that you totally understand addition of fractions. Not by shortcuts, but by a method that's pretty much what I wrote out here, which I believe is the way it's presented. Okay. Now, some people are using cross multiplication, which works fine if you just have two fractions. If you got three fractions to add, cross multiplication, you're out of luck. So that's what you know, it's not going to help much when you get a slightly more complicated expression. Okay. So I don't recommend that you shortcut it just to get the answer here. Or, like this. So take that for what it's worth. Now, this might be the hardest thing in the course. The hardest algebra in the course, okay? Now, the algebra gets a lot harder than this, but the level of pre-calculus doesn't get a whole lot harder, okay? This is something that a deficiency in algebra, when you get to this in pre-calculus and get more complicated expressions, it's not going to make you happy. Try to understand this. I'll also qualify all this by saying, of the challenging topics in pre-calculus, this is probably the least important one, but it's in the course. Okay. And it is important to have algebra up to the level of this sort of thing, especially if you go on beyond pre-calculus. Okay, a question about the quadratic form. I feel we do pretty well with that, but when you're into this, it's easy to get something wrong with the quadratic formula. So let's see what's a quadratic formula. Tell us about numerator 2x squared minus x plus 123. Now, what the quadratic formula says is that this equals 0 if and only if x equals, well, a is 2, b is -1, and c is 123. I assume you remember the quadratic formula. If not, go back to this part of the video, get the quadratic formula in front of you, and make sure you understand, because you do have to understand the quadratic formula. Now, we just went over that last time because due to an error in sequencing, or due to my not realizing we hadn't been over the quadratic formula, which comes a little bit later in the course, we digressed to the quadratic formula, okay? So it's good to understand the quadratic formula at this point. You'll have to understand it later in the bigger context. So here's how it works. This is negative of -1. Well, since we haven't been over it, I'm rethinking what I'm going to do with it. So Here's the formula. Okay. And you want to learn that formula. You don't want to go through the rest of your life without that formula. If you're going to take pre-calculus and hopefully, at least an applied calculus course, you're just going to need it. Okay, well, B is a number in front of X. Okay. The number in front of X is -1. They don't have the 1 there, but we understand the negative X is -1X. Okay. So that's a negative of -1. And B is -1. It's the number in front of X. It's negative B squared is that the square of -1. Be sure you write parentheses around this for squaring a negative, especially if you're going to punch it into a calculator, okay? Because if you don't have the parentheses around it, it's going to square the 1, then it's going to attack the -1. Whereas the square of -1 is -1 times -1, which is +1. Okay? And that's not what you're going to get if you're not careful. So anyhow, it's -4 then times A. Well, A is the number in front of X squared. That's 2. And C is the number you got left over here. That's 123. And 2A is 2 times 2. If you do the arithmetic here, let's see, 8 times 120 is 960, so that's 984. And that's -983. If I multiply correctly, and you always want to check me on that. Okay. At this point, square root of negative is not a real number. It's an imaginary number. Okay. Since you have a negative here, you're not going to get any real zeros. Not a real number, since no real number has a negative square. I'm going to just say, okay. Square root of 900, negative 909. Square root of negative 983 is. I wear this from circulating. Don't really have to wear it up here, but I'm so used to the plain thing. Okay. If anybody wants me to wear it up here, just let me know. I will. I want to support people that wear their masks. Okay. Still think it's a good idea. Okay. This is not a real number, since no real number has a negative square, right? So this thing is never 0. At least not with real numbers, which is what we're talking about now. They're complex numbers that make it 0, but they don't show up. They don't help to factor anything. Okay. Okay, well, again, talk about the logic of this, which is challenging and worth thinking about. If it did factor, you'd end up with a 2x plus or minus some number times x plus or minus some number equals 0. Okay? In other words, if it did factor, well, if it factored, then set this equal to 0, you'd get a solution. X would just be negative 1/2, whatever you got over here. Okay? So this would be 0 if 2x plus or minus whatever this is equals 0, or x minus or plus whatever this is 0. In other words, you factor it into two things. Each of these things could be 0. And if one of them 0, the whole thing is 0. So this would contradict the idea that this thing can't be 0, which you've proven using the quadratic formula. Okay? Now, that's really worth understanding. Okay? But if your short-term goal is just to do well in this course and, you know, pass it and move on to the pre-calculus course, you won't need to understand it for this course, but it will help you in pre-calculus if you understand this now, at least if you ponder it enough to get the brain cells working. Okay, so if you have time, it's worth looking back at this whole idea here. Okay, now what's really necessary though is that you can get from here to here. The theory of all the rest of it is really beneficial, but I'm not going to be testing it. Of course, if you understand the theory, you're more likely to do everything right. So you weigh out, you know, against how much time you have and just how much you want to beat your head against these ideas. Okay. So there we have it. Okay, very good. See if I can get this thing to stop. Okay, just to show the board as clearly as possible, because at some point it zoomed itself back. Here it is. And here it is. If you're reviewing this or seeing it for the first time and didn't see everything, hopefully you can see it now. Okay, well, the pretty picture got everything in focus, so that's good. Okay, complex fractions. Example. Five eighths divided by 3/5. It could be written out like this. Okay. And of course, when you divide by a fraction, you multiply by the reciprocal. So that's 25 over 24 in the last step. What you need to see is this divided by this, or this over this means this divided by this, and division is multiplication by the reciprocal. First thing you got to understand. Okay, let's apply that idea to this thing here. Okay. Now, your numerator needs to be expressed with a common denominator. And your denominator needs to be expressed with a common denominator. Okay. So I'm going to keep the fraction in the form of a complex fraction, but I can say that, okay, We'll make that x over 1 times 8 over 8 and 2 over 1 times 5 over 5. All I've done here is said, well, the only denominator I've got here is 8. So I got to express x with the denominator 8, so it'll match up with this. Okay. And down here, I got a denominator of 5. So I've got to multiply, I've got to express 2 with denominator 5. Okay. And that's easy to do. To express x with denominator 8, I multiply x over 1 by 8 over 8. And to express 2 with denominator 5, I multiply 2 over 1 by 5 over 5. For the reasons that we saw earlier. So now I've got x over 8 plus 5 over 8 divided by, I'll write 3/5 x is 3x over 5. 3/5 times x over 1. And 2 times 5 is 10, 1 times 5 is 5. So now my numerator has common denominator 8 and my denominator has common denominator 5, right? And I work these out separately. So now I see that my numerator is just x plus 5 over 8 divided by 3x plus 10 over 5. Okay. And that equals well, that's a division. Actually, I'm skipping a step. I want to do that. That equals x plus 5 over 8 divided by 3x plus 10 over 5. Well, I'm out of room, so I've got to come back over here, but that equals then x plus 5 over 8 multiplied by 5 over 3x plus 10, because division is just multiplication by the reciprocal. So I just flip the numerator and denominator, get the reciprocal, and here I have it. I multiply my numerators and I multiply my denominators. And then I go ahead and multiply through by the 5. I get 5x plus 25 over 24x plus 80. And I don't have any common factors here. Okay. So what I'm going to ask you to do is one that's just a little more complicated than this, but I want you to try to imitate every step that you see here and think about why those steps work. So let's say I've got this. Well, what was my first step here? I started out from here all the way over to here. I worked out in 3 steps how to put the numerator over common denominator, how to put the denominator over common denominator, right? Found a common denominator for the numerator, common denominator for the denominator. And that gave me something that was pretty easy to deal with from that point on. So see what you can do. Okay, that we're short on time, so I'm just going to kind of run through this quickly. But this is common denominator is going to be 4, so we're going to multiply the 7 by 4 over 4. Common denominator down here is going to be 2 times 7, which is 14. And I'm just going to say, okay, that's x over 2 times 7 over 7. Plus 3 over 7 times 2 over 2. So if the denominators match. And that equals 3 dots here. Okay, if I multiply that out, that's going to give me 28, and I'm going to have 4s. So it's going to come out here. Make sure you understand what goes here. And then it's going to be you're going to have 7x and 6, and you're going to have 14 for your common denominator. So you're going to get 7x plus 6 over 14. Don't skip that step. Make sure you fill in that step. So that's, well, I need to write it there. And you want to write down that division step just to reinforce why you flip this thing over. You just get used to just, okay, we flip this one over and don't understand that's division, and division is multiplication by a reciprocal. Then you're not reinforcing that essential idea. It's not going to be as likely to be there for you later if you need it. Okay, well, that's 2x plus 14 over 4 times 14 over 7x plus 6. And if I multiply 14 by 2x plus 14, I get 28x. Is that really 2x plus 14? That's 2x plus 28, isn't it? Yeah, 7 times 4 is 28. So that 14 is 28. And 28 times 14 is 196 times 2, which is 392. If I multiply it right. And that's over 28x plus 24. And there's an impulse, you want to cancel out that 28 because people talking cancellation, that doesn't work at all. Okay. 28 is not a factor of the denominator. It's not a factor of the numerator. Okay. You could simplify the fraction. You know that 2 is a factor of everything here, and so is 4. So you could divide all these numbers by 4 in the numerator and denominator. You factor 4 out of the numerator, factor 4 out of the denominator, and then you could get rid of those 4s, but don't have room to do that, and we're out of time. But that's the process. Try not to skip steps. Try to do the steps so you're reinforcing the principles.